This video is on the objective identify the null and alternative hypothesis involving the hypothesized mean of the differences for the paired data. Now this is the second video I'm putting up related to this objective. Hopefully you have seen the first one. And again, I'll say anytime you see the words paired data, means you're going to have two dependent samples, and each pair of data, one from the first sample, corresponding to one value from the second sample, each pair of data will correspond to a single individual. And I'll describe more of what that means in a second. All right. So again, if you want to see more about the topic, please click on More Instruction. Look at their videos, their notes, their examples, and hopefully those help you. Okay, so here, a therapist believes that the music a child listens to may have an impact on the amount of words on a list they can memorize. In order to test this, she selects a random sample of children for an experiment. She has the children look over a list of 100 words for 5 minutes while listening to classic rock music. After the 5 minutes, she tests the children to see how many words they could remember in the order of the list. She then does the same experiment, this time with a different list of words, but the same children though. Okay. While listening to classical music, if we let D be the difference between classical and classic rock, D equals basically the number of words they could remember after listening to classical music minus the number of words they could remember after listening to classic rock. Identify the null and alternative hypothesis for an appropriate hypothesis test. All right. So here's what's happening. All right, and I kind of went over this on the first video on this objective, but here's what's happening. So she's taking these children, right? I'll say child 1, child 2, and so on, all the way up to say, child N. And then for each of these children, she's having them listen. Again, I'll say she's recording two things for each child. Sample 1 is the number of words, right? The number of words the child could remember after listening to the classic rock. I'll say number of words, after listening to the classic rock for 5 minutes. Right? Sorry, child 1's there. Okay. And then a second sample, she records a second value, so a whole nother list of data, but they're going to be dependent because each pair of data will be related to a single child. The second sample is the number of words the child could remember on this different list after listening to classical music. All right. And so say for child 1, say after listening, I'm just throwing out some random numbers here. All right, so don't worry about where these came from. I'm just making this up. So the first kid, after listening to classic rock, say on this list of 100 words, say after listening to classic rock while trying to memorize them, say the child remembered 24 of them. All right. But then this other list of a different 100 words, this same child, after listening to classical, say they remembered 31 of them. And then for the second kid, after listening to classic rock, they remembered 42 of the words from the first list. And say after listening to classical music, they remembered 34, words from the second list. And I would do, she's doing this researcher, for all N children in her sample. say the nth child remembered 14 words the first list, and then 27 words in the second list. All right, now what we're going to do with these, this is called paired data. Right? Paired data, again, because each pair of data, every value in sample 1 that corresponds to a value in sample 2, they're both related to the same individual. Right? So this pair of data is related to child n. This pair of data is related to child 1. So I can't mix these around, right? I can't just shift these around. I couldn't switch the 27 and the 31 because the 27 is related to child n, the 31 is related to child 1. I couldn't just mix them up. And paired data is also these samples I've written here, the classic rock sample, the classical sample. These are therefore dependent samples, clearly, because there is a link between them, the child. Right? There is a relationship between them, what child you're talking about. All right, so in these cases with the paired data, what we're going to be doing is taking a look at the differences in these sample values. So I'm going to make a whole new list of differences. Now they called that D, right? And they're asking us to take, the number of words they remembered after listening to classical music and subtract the number of words they remembered after listening to classic rock. Right. So if I were to look at all the, let's say D1, right, the first difference for child 1 would be, 31 minus 24, that'd be 7, meaning they remembered 7 more words after listening to classical than they did after listening to classic rock. Then difference number 2, D2, 34 minus 42, is negative 8, meaning they remembered fewer words, 8 fewer words, after listening to classical than when they listened to classic rock. And I keep doing this for all n children in my sample. Dn, the nth difference here in this paired data would be 27 minus 14, be positive 13. Okay. And then this sample of differences, we're going to work a lot with those. We're going to take this sample of differences. You're going to end up having to find D bar. All right, I've written this before, but D bar is the mean of the sample of differences, the mean of all these n differences here. So the mean of the sample differences. And you're also going to need to know S sub D. SD, that's this, remember little s was standard deviation of a sample. This S sub D is the, the standard deviation of these n sample differences, of the sample differences. So let's say sample diffs, right? All right, and then when we write our hypotheses, what you're going to hypothesize about the parameter is going to be, okay, I looked at these differences for these n children. What if I did this for all children? Right? Because this is only a small sample of children, n children. What if I did this for all children? Well, then we'd look at the average. We'd look at the average mu of the differences, for all kids. That's what we're going to hypothesize about. So you're going to see this mu sub d a lot, and mu d here. This is the population mean difference. Okay, so if I were to do this for every child, right, all children, how many words did they all memorize after listening to classic rock? How many words did they all memorize after listening to classical music? Then I'd subtract those and get all possible differences, the difference between classical and classic rock for all children, and then take the average of all those. That's this mu d. All right. And our hypothesis will be about this value here. All right. Okay, so every hypothesis starts with a claim, right? Some claim, some belief, some statement being tested. Now I go back to the first sentence I'm looking at here. It says, a therapist believes that the music a child listens to may have an impact on the amount of words on a list they can memorize. So, she's not saying it's going to increase it or it's going to decrease. She's just saying that there's some sort of impact. So her statement is that the average difference between the number of words listened to by different, after listening to different varieties of music is not 0. Meaning that there's some sort of impact, right? There's some sort of change. Now, whether it gets greater or less, she's not saying that. So this is saying, this is saying that different types of music have an impact on memory. Different music has, some impact on, the number of words that the kids could memorize or on memory, but some impact. Doesn't make it better, doesn't make it worse, she's saying. So this mean difference is not 0, is her claim, or is her belief, what she's going to be testing. All right, so then you have your hypotheses. Null hypothesis, alternative hypothesis. Again, the claim does not involve equality, so that'll be represented by the alternative hypothesis, and then the null hypothesis is the opposite of that, right? And this is what you're going to assume when you run the test later. Right? We're going to assume that the average difference is 0, meaning that there is no difference between musics. There is no change, there is no impact. So this is basically, you'd be assuming there is no impact on memory, and then the alternative hypothesis is that there is an impact somehow, whether it be greater or less than. But this would be a two-tailed test, remember, not equal. And we'll get to all that stuff later as well. All right, so let's keep this in mind when we go back here. Now they wrote it out in words. What would be the null and alternative hypothesis here? Well, I already told you, the alternative is the third one, the population average difference. That's that mu d, right? The population average difference in words recited is not equal to 0, meaning there is some sort of impact by the different kinds of music. And the null hypothesis, the population average difference, that's the mu d in words recited, is equal to 0. This is saying in words what I wrote in symbols on my paper with that mu d. Wonderful. All right, and again, I'm hoping that watching me go over this, looking at the more instruction when necessary, reading your answer explanations when they come up, I'm hoping all this stuff helps you out when you're looking at this on your own. And thank you very much for watching.